4.1 day 2, let's keep it going. So you asked me to find all the extreme values of this function on that interval. Well, since this is a continuous function, as long as you stay away from 0, and the interval that I'm looking at does not include 0, it stays away from it, then this is a continuous function on this closed interval. So as long as you're in here, it's continuous. That means that the extreme value theorem applies. So it means there does actually exist an absolute min and max in this interval. So using the closed interval method, step 1 is find the critical values, which is where is the derivative undefined or equal to 0. So I take my derivative. So if this is my function, its derivative is this, right? And so if I just look at this and then ask where is it equal to 0, it's not easy, right? So same thing for undefined. Remember, we like factors. We like factors and fractions when finding things equal to 0 or undefined. Factors, because two things multiplied together equal 0, and fractions, because if the denominator is 0, that sucker's undefined. So first thing we do after we get this derivative is rewrite it like so, but then we have two terms. To get it to be one term, we multiply this by x squared over x squared, and we end up getting this as our derivative. And that's great because it is one term. So now for that derivative, where is it equal to 0? Well, that's where the numerator is equal to 0. So that gives us plus or minus 1. And over here, where is it undefined? Well, that's where the denominator is 0, and that gives us x is equal to 0. But look, plus or minus 1, those are critical values for the function. But on my specified interval, notice up here, -1 is not in this interval. So x equals 1 is the only critical value from this piece. And then over here, x equals 0 is a critical value for the function, but it's not critical to the current conversation because 0 is not in this interval. So the only critical value that we're going to worry about is 1. So now for step 2, I'm really only focusing on f of the critical values that are in my interval. So f of 1 is 2. And then f of the endpoints, give me these values. So now step 3 just says, look, one of the biggest and smallest that you see out of step 2, the absolute max is here. F of 0.2 is equal to 5.2. And f of 1 is 2. All right. Let's look here. 57. If this is my function on this closed interval, well, guess what? This is definitely continuous because it's made of sines and cosines with no division on a closed interval, so the extreme value theorem applies. Again, this is an existence theorem. It says there exists an absolute min and max for this continuous function on that closed and bounded interval. So using the closed interval method, step 1 is to find out where the critical values are, where the derivative's equal to 0 or undefined. So I take my derivative, right? And I would get this. Now, setting it equal to 0 is not pretty, but we remember, we like factors and fractions. Factors because two things multiplied together to get 0, one of them must be 0. And fractions because if the denominator is equal to 0, our function's undefined. So we change the form, something that you wouldn't have to have memorized, but you have to know enough to know if it's double angle, there might be a way to rewrite it and you look up your double angle formulas. So this turns out to be this. And why is that great? Because when we replace this with this, well, then I can distribute the 2, get this, and then rewrite it as a quadratic function. So it's quadratic inside. So where's this derivative equal to 0? Well, I just set this whole thing equal to 0. Well, I'm going to move it over to the right-hand side so that the leading coefficient is positive. And then I'm going to divide by 2 to make my life easier. So now from here, I think it's a quadratic. And to really see it, I use u substitution. I let u equal to the sine of t. When you do that, you now have 2u squared plus u minus 1 equals 0. So that means I can factor. Well, why is that great? Because if two things multiply together to get 0, either the first one is 0 or the second is 0. So I get u is a half or u is negative 1. But remember, u is sine. So if you ask me to solve sine of t is equal to 1/2, say, look, sine is just y. So where's the y coordinate equal to a positive 1/2? Well, it's either pi over 6 is my reference angle. And so over here, if I go back from 6 pi over 6, 1 pi, I get to 5 pi over 6. All right, here, where do you get negative 1? Well, I know my quadrantal angles. That's just 3 pi over 2. So then I go up here and look up here. Do you see that 3 pi over 2 is not in here? A negative pi over 6 is not in here. So the only possible value is this pi over 6 is the only one that's inside our interval. So all of these were critical values for the function, but the only one that's critical to the current conversation is pi over 6. So step 3 is we evaluate f of my critical value and f of my endpoints. So step 3 just says, look, the biggest one that you see there is your absolute max. The smallest is your absolute min. And then where's that undefined? Just so you know, nowhere, because it's sine of t, right? 59, 61, 69. There's a bunch of these. Okay, so we just did 57. So let's look at 59. Now I've got this function. Well, note f is continuous on this interval. Really, the only place where this thing is going to have problems is because of this at 0, which is outside here, and because of this at 0 or negative, which we don't have to worry about. So extreme value theorem applies. I say, look, critical values are where the derivative is equal to 0 or undefined. I take my derivative. I do the product rule. First derivative second, second derivative first. And I get this, but notice it's two terms. And we like factored fractions. So either things that are factored or things that are fractions. Turns out here, I just want one term, yeah, that one fraction. Why is that great? Because now if you ask me where's the derivative equal to 0, I set the numerator equal to 0. So I get this. And when you get to here, that just means that e to the 1/2 was equal to x. If you ask me where is it undefined, I set the denominator equal to 0, and so I get x equals 0. So for my function, these are critical, but to the current conversation, the only one that lives in here is this one. So now you evaluate f of the critical values, and you get this. F of the endpoints, you get this and this. Thus, step number 3, the only absolute min and max is this and this. Absolute max is the first one. Absolute min is f of 1/2 is approximately equal to negative 2.773. Alrighty then, 61. Again, remember natural log is okay as long as the input is positive. Well, guess what? This crap right here is always positive because you're going to square something, right? You're going to add x plus 1. Well, the most negative you ever get is plugging in a negative 1. Negative 1 plus 1 is 0. Negative 1 squared is 1. So this thing is always positive. Cool. So this thing is defined inside here. So since this is continuous on a closed interval, extreme value theorem applies. Now using the closed interval method, we say where does the derivative equal 0 undefined? And first I got to find the derivative. When I find the derivative, I get this. Well then, where's the derivative equal to 0? I'm happy because it's a fraction, so that's where the numerator equals 0, which gives me negative 1/2. And where's it undefined? Well, that's where the denominator equals 0 for a fraction. And that gives me no real solutions. If you don't believe me, try the quadratic formula. So negative 1/2 does live in this interval, so I'm happy. So now I just evaluate f of the critical value. I get negative 0.29. F of the endpoints, I get 0 and 1.1. Thus, from step number 3, the absolute max is f of 1 is 1.1, and f of negative 1/2 is about negative 0.29. So for the last one, if we have this, it says, think about this thing, but what is the maximum value in the first 3 hours, right? Well, first 3 hours just means on 0 to 3, so we can use the closed interval method because this is continuous on a closed interval. So I say, where's the derivative equal to 0 undefined? I take my derivative and I get this. Well, notice actually I get this thing right here, but then we remember we like factored fractions. Factors and fractions. So we factor out the common factor and we get this, which is so much easier to find the critical values of. Where is this undefined? Nowhere. Where is it equal to 0? Well, either this is equal to 0 or this is equal to 0. That's never going to be 0, but this just gives you about 3.6. So step number 2 is to evaluate f of the critical values, f of the endpoints. And it turns out that the largest that we ever see is this value. And so that is the max blood alcohol content is 0.177 milligrams per milliliter, and it occurs at approximately 0.36 hours. That's 21.4 minutes. Awesome. Have a great day.